Hi, my name is Laurence, former competitive climber, avid surfer, and outdoor enthusiast. I'm a 22-year-old recent college graduate from Los Angeles, and I am a world record-holding rocket scientist. I joined Codesmith because I saw the opportunity to uniquely position myself with the ability to leverage my astronautical engineering degree and my experience as a full-stack developer, essentially reframing my career with endless possibilities. After the first 3 months in the program, we are tasked with individually building a full-stack application. Naturally, I decided to pay homage to my career by building a MERN stack that tracks upcoming rocket launches live with the help of an API. MERN is an acronym for the 4 key technologies that make up the stack. It uses MongoDB as the database, Express as the web framework, React as the client-side JavaScript framework, and Node as the JavaScript web server. Codesmith didn't just teach me new technology, but rather it conditioned me to learn rapidly and improve on the fly. In just 3 months, I honed in on how to make informed decisions about technologies in order to foster an optimized development process. I knew the efficiency of the project would be rooted in my preparation, and as a visual and tactile learner, I understand that I develop best when I visualize what I am building from the project's inception. After writing a quick brief to arrive at a concrete idea of the core features I felt were absolutely necessary, I began to visualize what my project would look like. Using Figma, I went through 8 iterations of designs for my user experience and interface. Doing this enabled me to get insight into what type of API I wanted to pull data from, what models I needed in my database, which middlewares and routes were necessary to achieve my desired functionality, and what challenges I was taking on in React. I leveraged my skills in InDesign to create unique space components, finalized a colorway that I felt suited the project best, and selected glass morphism as the UX design trend that I wanted to incorporate throughout the project. After finalizing a design that I found attainable within my given timeframe, I used a prototype feature in Figma to get a culminating idea of the look and functionality of my project. And with that, I was on to the hard part, actually coding. In terms of my minimum viable product, I decided to create 2 models for my database, one for the data stored on each individual launch and another for the data stored on each user. MongoDB uses JSON-like documents with dynamic schemas, which came in handy for cherry-picking data from what would eventually be returned from my fetch request to my API. For my launch schema, I chose these defining properties and set their data types according to what I knew the API would respond with. For my user model, I chose username and password as defining properties and set their data types accordingly. In order to demonstrate more advanced authentication, I chose to employ bcrypt for password hashing. Bcrypt's unique salt allows for 2 people with the same plaintext password to have different stored passwords. Furthermore, using the salt work factor, we can customize how slow bcrypt performs the hash, which protects against brute forcing an individual user. Next, I decided to create 3 controllers. The first controller fetches data from my database, sifts through the data, and stores the desired values as a launch model in my database. The second controller handles creating, authenticating, and authorizing users. Initially, the controller grabs all existing users from my database. Having an object of all existing users allows the create user and verify user middlewares to discern if a username already exists and therefore needs to be authenticated, or if the username does not exist and therefore needs to be created. The final controller creates a cookie with the value that is set equal to the ID of the current user. Following best practices, I made sure to set the cookie as HTTP only. This means that the client-side JavaScript cannot access the cookie, which in turn mitigates the probability of it being stolen or manipulated by malicious JavaScript running on the client. After successful user authentication, this cookie is sent in the response. To wrap up my backend, I have my routes. On load, the front end makes a GET request to the upcoming launches endpoint, which employs the SpaceX router. The SpaceX router uses the Get All Launches middleware located in the SpaceX controller to make a fetch request to my API. The request is followed by a response with an array of the 25 most recent upcoming launches. This array is then sent to the client in a response object. In a similar fashion, I wrote authorization routes for when a user signs up or logs in. If the sign up or login is successful, the route redirects to the upcoming launches endpoint. If, while logging in, the verify user middleware cannot find the existing user, it redirects to the sign up endpoint. Kicking it off with my index.js file, I use React to render HTML to the web page by using a function called render. The purpose of the function is to display the specified HTML code inside of the HTML element with the ID of app. We get that element by using the vanilla.js method getElementById, which grabs my app element from my index.html script. Additionally, I have my functional React component app nested inside a React Router DOM component called Browser Router. This component uses the HTML5 history API to keep my UI in sync with the URL. Moving on to my components. My aforementioned app component uses Browser Router as well to hold two route components. Each route component is responsible for rendering UI when its path matches the current URL. When the URL has a login endpoint, the route component renders the login page component. Otherwise, the route component renders the launches component. The launches component is where I had the most fun. I began with initializing my state, which is a built-in React object used to contain data or information about the component. My state will change over time, and when it changes, my component re-renders. In my component did mount, which is a method called immediately after a component is mounted, I make a fetch request to my backend to grab the array of upcoming launches. Then, I use the setStateReact hook to set the launches stored in my state equal to the array returned from my fetch request. Setting state here triggers a re-render, which in turn displays my array of launches as launch tiles. These launch tiles are created by using the map method on my array of launches. This creates a new array called launch elements, which is populated with a launch tile component for every element in the launches array. The launch tile component takes the information that is passed to it during the map method and structures it into a tile that shows information about the individual launch. Using copious amounts of SCSS styling and conditional rendering, as well as achieving flipkart functionality in React, the launch tile is able to display the impending launch date and an image of the launch vehicle on the front, as well as various launch attributes on the back when flipped. The login page component is relatively simple. It renders a login form with fields for the username and password, as well as a submit button. Users can input the values on the form validates the username and password entered by the user, and it redirects to the upcoming launches page when the login is successful. With both my backend and frontend completed, I decided to use Webpack to deliver a small, widely usable bundle. Webpack will help with future scale, maintainability, and faster load times by writing configuration to utilize hot module reloading, ES6 Plus transpilation for developer packages, and using minification and uglification features to decrease the bundle file size. And that is how I built a full-stack application featuring MongoDB, Express, React, and Node in 8 days. Thank you for listening.